everyone. Welcome to our first live classroom. I'm pre-recording this because I've been having network challenges. I'll be uploading it shortly. I'll also be joining at the regularly scheduled class time so that if there are any questions, concerns, or whatever that may not be covered by this, that they can be addressed. So jumping right into our agenda, we'll go through an introduction where I'll introduce myself. We'll go over the course where I introduce it. We'll talk a little bit about this week's objectives, some reminders, a little bit of a discussion around the learning environment, and then a live discussion, and then lastly, the importance of distributed architectures. So a little bit about me. I have a doctorate in computer science from Colorado Technical University. I have a master's in computer science and a bachelor's in business administration, both from West Virginia University. I have a lovely wife, 4 adult children, and 3 grandchildren, soon to be 4. We live on my wife and I live on a 74-acre farm. We have pretty much way too many animals, roughly a dozen or so cows, about that same number of sheep, and about that same number again of goats. So lots of animals. Jumping into the course overview, it's a good idea to understand what the objective is of a course, and so we'll go through it in detail here. From the syllabus, this course is the study of the design and use of distributed software applications as part of an enterprise architecture in a typical business. There's some pretty important words there. Distributed software applications, really important. Enterprise architecture is also very important. Enterprise architecture is related to systems and applications at an entire organization level, not just within a particular division. It's about how things talk together, and they're typically pretty important systems. They're things like payroll that keep the company running. This course places a focus on the software development process, business process analysis, and generating functional requirements for business technology. So it's not just a programming course, it's a very broad sort of course in the sense that we talk about a lot of kind of softer type technology or issues rather than just technology. We do talk a bit about technology, but it's not as in-depth as perhaps a computer science course might be. The topics include software architecture, business process analysis, agile development, and scalability. Kind of the whole point of distributed architectures is to enable scalability, and we'll talk more about that later on. This course will prepare students for producing software development project plans. So you'll learn how to basically be able to create a project plan, documenting hardware and software requirements. Requirements are a critical part of pretty much any sort of system experience. So we'll be talking about that to some extent, and also to support future and current transaction loads and modeling end-to-end data flows for a given business process. So pretty interesting stuff. Gives you a pretty good idea of what we're going to do in this course. So jumping into the course introduction, goals, and objectives a little bit further, by the end of the course, you should be able to define and describe a system in detail. So what is a system? And why do you need to be able to do that? Because it's kind of important to be able to do it. This talks about in the slide that it carries into a subsequent course. That was true at some point. It's no longer the case. I probably should update the slides to reflect reality. Took me a while to learn that fact because it wasn't terribly clear. But anyway, the basic idea is by having those skills of being able to document things to the point where somebody could actually build it is really important in subsequent sort of experiences, and especially when you get into the real world. You may have an idea in your head of how something should be built, but if you can't put that onto paper, it doesn't matter too much, right? So that's an important skill, is learning how to be able to represent the ideas that are in your head in a way that is consumable for others. You should be able to diagram a system, and in this course we'll be using Lucidchart. It's a free online version. Why are we using it? Well, it's free, it's online, and things like Visio are really nice, but they're not free. They're also not as pervasive, perhaps, and also there's a fair amount of documentation, YouTube videos and such about Lucidchart. So it's worth kind of the experience, and is a pretty decent tool, really. Communicate good technical writing skills. So at the end of the course, you should be able to write in a technical way. Technical writing is a bit different than perhaps some of the other types of writing you might have experience with, but it is something that is important to hone and attempt to learn. Whenever we do technical writing, it's typically much more concise, and it's a very neutral sort of tone. It's very similar in a lot of ways to scholarly writing, perhaps a little less rigid and structured than that, but yet it's still, the intent is to inform, not to entertain or to engage necessarily, though we do try to keep things concise and to the point so that the readers actually finish reading. You do want to use your free Grammarly.com account. You get it with your Rasmussen email address. You want to use it. It will help you become a better writer in general in this course and in others. A high-level distribution of where the points are. This is something I do typically whenever I'm taking a class, is I take a look and figure out where do they come in from, because if I don't know that, I might miss something that's really, really important. So as you can see here, course project, pretty good chunk of your points. So you want to kind of keep that in mind. A live classroom, not so much, right? But still, it's 3 percentage points on your final grade is 3 percentage points. Sometimes that can be the difference in a letter grade, depending upon where you're at on everything else. For the project overview for Module 1, you kind of start off with, there's a theme here. These things run together. And the idea is that you're going to be creating a set of documents that correspond to an application that you might like to build at some point. It does not have to be something you actually have the skills to build or the time to build or the capability to build, but something you think should exist. So, and have fun with it. It doesn't have to be necessarily tied to the Rasmussen environment or to any particular course or school within that university. Instead, it's something that you think should exist and something that should be built. So think about it, and they should all kind of go together. They should dovetail together. At the end of it all, it should kind of make sense in a concise sort of way. So start thinking about what would an app that you would build do. So what is the features it would do, and why would somebody care to use it? Activities, each module typically, except for the first and the last one, have activities that you do. In Module 2, you're going to be setting up Lucidchart. We're not quite there yet, but it's a relatively simple thing. You'll just want to document the fact that you've set up the account. Then you'll create a business process diagram. Again, this is in Module 2, not something we do just yet. For this week's objectives, first of all, rubrics. They're important. You need to know about them. You should care about them because they are how you will be graded. It is how I come up with your score. So look at them and make it easy for me to find the things that are on that rubric so that you can get the maximum value from your score. You want to read the introduction in Chapter 1 in Event-Driven Architectures and how SOA enables the real-time enterprise. Then you'll do a post and reply. Unless there's an increase in students, it'll probably be, we'll likely forego the requirement of responding to other students because it would be me or yourself, but we'll see what happens. Who knows, maybe somebody else will come in. The Module 1 course project is around feature identification. So jumping into the rubrics, so they are important. If you don't know this already, it's how you're going to be graded. So anytime there's a rubric, you want to look at it because it's a cheat sheet to let you know exactly how the instructor is going to assess and rate your work. So make sure that you do take a look at them. You grade yourself ahead of time is always a great idea. So take a look at the rubric, take a look at what you've got, and check it off. Is everything here that's supposed to be there? Is it easy to find? Is it clear and concise that you've met the rubric quantifications? You'll find the rubrics in each week's announcement. I include them there for your perusal. Do take the time to take a look at them. It's to your benefit. For your discussion, for your initial post, what are your initial thoughts about the advantages and disadvantages of a distributed application architecture? Consider things like ease of implementation, efficiency of performance gains, volume of data concerns, securities issues potentially, and synchronization and distributed data. For now, unless there's somebody else, you typically should be responding to someone else and adding to the conversation. We'll see how that goes. If I give you something to work with, maybe you can respond to that. Expectations of the prompt, don't just copy and paste the prompt, instead rephrase it in your own words. It's a good practice in every course because it's not like something you did back in grade school where you write down the question you're asked to answer and then answer it. Instead, you should have a cohesive sort of response to it, similar to you would if I were to ask you that question in person. If I said, what is the advantages of a distributed architecture? You wouldn't parrot back the question I just asked you. Instead, you would say, well, I think the advantages of a distributed architecture are. So you're rephrasing my question as part of your response. Ensure that all of the elements of the prompt are addressed. In this particular case, it is the advantages of distributed architecture, disadvantages of distributed architecture. and supporting arguments for each. So what are the advantages and disadvantages, and why are they advantages and disadvantages? I don't particularly care about word counts. You should, though, exhaustively cover the topic, so don't just write a sentence and think it's good, unless you can truly answer all of those concerns in one sentence. And if you did, it would be a pretty complex one because there's at least 4 or so thoughts there. So be very challenging. But do make sure that you cover the topic completely. The rubric for the discussion, and this is also in the announcements, you'll get 1 out of the 10 points just for not copying and pasting. So if you restate the prompt, you get 1 point. Then you respond completely for spelling and grammar 2, and then you'll get 3, most likely, because, there's not many people here. Course project, module 1, list 4 to 7 of the important features for your application that you would like to create. It does not have to be a Rasmussen College's School of Technology app, rather just an application that you would like to create. Be creative, have fun, do something interesting. Make sure that it's reasonably long, but you don't have to make it overly long. So it should be something that is concise and communicates the goals of the application in a way that somebody could envision it in their head, and potentially even start thinking about how they would go about building it. Make sure that it's reasonably realistic. You're not going to actually build it, as the slide says, but it is important to know. And you may want to start pulling together an elevator pitch about what that is, which is essentially something that the history, if you don't know it, is something that could be described whenever you were riding in an elevator with someone over a few stories. So maybe 2 to 3 minutes in conversation. It gives you some idea. It needs to be fairly concise, gets to the point pretty quickly of what's the point, justification of why it's important and why it should be built. Think about the features, 4 to 7 features, and you want to come in somewhere around there. Make sure you have a feature name, a description, and how it gets triggered. So does it happen whenever the application starts up? Does it happen whenever the user clicks on something? Does it happen in response to some event that were to occur? So there's lots of different ways that features could get triggered. For the module's expectation, it doesn't have to be APA, but you can certainly do so if you wish to. You do want it to be reasonably grammatically correct, not a ton of spelling or grammatical errors or structural errors that are terribly obvious. Make sure it's pretty well organized, and if need be, use headings to organize your material. It's always a good idea. Make it easy for somebody to follow what you're writing. It shouldn't be a scavenger hunt where someone has to hunt for the things. You should guide them along the process of learning it. You want to use formal and precise language. Don't use casual. Don't use first person. Make sure that it is clear, concise, to the point, matter of fact, but not colloquial or casual. So it should be reasonably well structured and reasonably formally written. The module 1 rubric for the course project, pretty much 40% for creating a mobile app or talking about the features that would be relevant in a mobile app that were to be created. Then you would talk about who's going to use it, another 40 points, and then roughly 20 points for roughly 2 to 3 pages of decent writing skills. Again, not necessarily a huge fan of word counts, but it probably will come in the neighborhood of 2 to 3, and that is in the rubric that came with the course, not something I created or selected, so you do need to try to get fairly close to it. Reminders, and this is a reoccurring reminder across this term. For this course, Central Time is the time zone that rules all others. That's because all of your deadlines, all of the meeting times, and whatever it might be, everything is in Central Time Zone. Do check your announcements. I typically will do 1 a week. If something's going on, I may give you an additional 1 along the way. If you have questions, let me know. That's my role in this experience, is to answer your questions, not just to be some sort of orator reading slides to you. Rather, is to help you and guide you through this experience. Now we'll talk a little bit about the learning environment, and probably most of you are fairly familiar with it. It's about the calendar, the modules, the announcements, and the content folders. This might have changed a little bit since we've recently changed to a slightly newer version of Blackboard, but it's kind of the same basic concept, I believe. The calendar, pretty useful thing. You probably want to take a look at it because you should find inside of that all of the due dates, all of the live chats. I went to the trouble of setting all that stuff up, so you may want to use it. Modules is where you'll go to work your way through the course. If you've taken other classes in Rasmussen, then this is certainly not new. In fact, if you've taken classes pretty much in any sort of Blackboard, I would almost dare say any kind of online educational environment, very similar experience. Announcements is where you'll see things as they show up on the homepage, kind of top left corner. Also, below that was the live chats. That's where the recordings will be after the fact, and where I'll put a link for something like this. So the fact you're watching this means you've probably found it. Content folders, where some of the content is that you're needing along the way, including kind of the links to the materials and whatnot that you might need along the way. The live discussion is the place where you will tune in to both ask questions if you have any, but it is also something that is required for this course. And to encourage you to attend, we will have these magic phrases. And the magic phrase this week is blazing saddles, primarily because the textbook author chose to use it in their text. So if they can use it, then so can I. Enter that into the live classroom quiz for credit. And so we'll have a magic phrase each part of the week. Again, the whole point of this, though, is for me to answer your questions if you have any as we're moving through this experience. Feel free to shoot me a message, text. Make sure you identify who you are. I'm quite busy, so if you just something random out of the blue and don't give me context, I may not be able to respond appropriately. So give me enough context that I can answer, hopefully, your question, or at least dig into it to find out the answers. Now for a discussion of distributed architecture, kind of the point of this course, and event-driven architecture. Kind of two different things, but they kind of go together really well. So why do we do distributed architectures? And the short answer is you can only get so big. So at some point, rather than making a bigger and bigger computer so that it has more cores, more memory, more disks, at some point you have to go with more computers and go wide rather than big. So the idea is that you take a set of computers that are perhaps not all that significant of scale compared to a big computer, big being something that is kind of arbitrary, but you have them organized in some sort of a cluster distributed fashion so that they can communicate with each other, and you can handle things like one of them going away. So maybe something gets sick and dies. If it does, then the work that it has done should be recovered by the others and so on. But the basic idea here is that it allows you to separate things out across multiple servers, increasing concurrency, and thereby increasing capacity, but not necessarily speed. It could actually be potentially, in terms of just brute speed, slower, because you're actually dealing with some overhead of distributed processing and so on. However, you are able to do workloads that you could not have done on a single computer, so the speed of a smaller job might not really be relevant, because at some point big doesn't work any longer. You've been using distributed architectures for years, you just haven't perhaps known it. If you go to any of the big social media platforms, definitely a distributed application. Pretty much every web application you go to of any size probably is running in a distributed fashion and has been for years and years. So not new, but not necessarily something that's all that commonly discussed. So we talk about key concepts of event-driven architecture. Slightly different concept. Event-driven architecture is around something that responds to something. So it's implementing a system which reacts, does something in response to the occurrence of some item of interest, so an event. It's typically related in terms of things like publisher and producers to create. So this whole concept of publish, subscribe is probably going to be something you're familiar with, or at least you should be by the end of this course. You typically have things that are producing events, you have things that are responding to them and listening for them, typically through some sort of a queued bust sort of architecture, so that if something comes in, you know that it came in and you're able to do something with it. Event processors, again, something that responds after a listener has listened for something to do something with it. A type of an event processor is something like complex event processing systems such as Stream Analytics or other types of CEP systems. The Azure Event Grid is a type of event grid or event-driven sort of architecture, typically related to things like serverless applications. And serverless is not a great word because there's probably a server, but it may be some sort of containerized thing rather than a physical, or even virtual server. Event reaction is something that occurs in response to an event, so it's something that is done, it's an action. A messaging backbone is typically the mechanism of conveying those messages from place to place. Typically, it's some sort of a queue or bus. Things like Service Bus, Event Hubs, Kafka, those sort of things come to play whenever you're talking about a backbone and a bus. And you typically need some form of message serialization and format. So you need to have a way of representing those messages so that they can be understood in a platform independent way, because oftentimes you're crossing platform boundaries with these systems. Related to event and distributed applications is this concept of service-oriented architecture. The idea of a service-oriented architecture, is the name kind of implies, there's services involved. Services typically have a very crisp boundary, so you can think of them as a black box with an interface that you interact with. That interface is typically expressed as a service contract. It's something that doesn't change over time. You don't make modifications to that contract, that interface. Rather, you create a new version of it, and so that you persist the previous versions for some period, and then eventually they will go away. That's where things become deprecated and you reach end of life at some point for those interfaces. So the idea, though, is that if I'm using interface 1.1 and you come up with 1.2, at some point I may be encouraged to move to 1.2, but 1.1 will continue to work as it did previously without any kind of interaction. So you won't break it by making some sort of changes. Generally speaking, this whole approach is utilized to increase loose coupling. You want things to be loosely coupled where there's minimal interdependencies between them. This also ties into this concept of separation of concerns. Do your thing and do it well is the idea. So you don't do a kitchen sink approach where you do everything, but you do one particular type of functionality. That's the service does that functionality, and not necessarily a bunch of different things. So you have multiple services, each one focusing on a certain type of domain or area. The general patterns that you're going to see is typically a service provider. Most of the time this is done through a web service oriented sort of approach. You pose a request, you get back a response. It's that sort of pattern that you'll typically see. There's also potentially brokers, registries, and repositories. These are kind of like a directory or a phone book of sets of services within an organization, or perhaps cross-organizational. So it's a way of finding something that does something you need it to do. And then you have some sort of a client, a requester, a consumer, or a client that is the thing that is talking to the service and using it in some fashion. It may be talking to a broker that is in turn talking to a service, but generally speaking, it is something that is used to consume essentially whatever it is that the service provides. So how do they work? And how do service-oriented architectures work? And generally speaking, as I've kind of alluded to it, most of the time, some sort of web service. Generally speaking, it's going to be something that's based upon WSDL, the web service definition language. Oftentimes, that is a variant of XML, but oftentimes they're also related to SOAP, which is maybe using WSDL under the cover. And also, there's typically, you've got some sort of REST sort of aspect to it, which is representational state transfer, which is basically generally based upon XML or JSON. REST is very popular and is probably almost at this point kind of the status quo or the expectation. The reason it's very popular is, generally speaking, it is stateless. It's also easy to interact with because of the use of URIs, making it very familiar. A person can actually interact with a REST service and compose the queries on the query string in a pretty easy way, assuming you're staying away from posts and so on. But even then, using some relatively easy to use tools like Postman, pretty easy to interact with. They're very much based upon the request response pattern, which is basically you post a request to the service and it sends you back a response. Or you may get a request to the service and get back a response, but it's very much the pattern of the web. You send something, you get something back, and that's the basic concept. They are typically self-describing messages, and they're relatively easy to understand, making coding for them pretty straightforward. So lots of reasons why REST is quite popular. With that, we've reached the end of this discussion. Again, I'm recording this as bandwidth has been a challenge for me lately, likely due to my service provider overselling during this wonderful experience. So if you have any questions, let me know. I will be joining during our scheduled time. If you have any questions, bring them then. Stay safe, and I'll talk with you later.